So yesterday we have discussed about some basic networking. What is an IP address? How to assign an IP address to Windows machine and important ESX machine. So that was about IPv4. Okay. In that there are two types of IP addresses: public IP and private IP. We'll see what is public IP. IP addresses which will connect to the internet directly or public IPs. Let's say in my laptop, if I want to connect to internet, if I want to connect my laptop to internet, okay, I need to assign one public IP. Okay, then it will directly connect to the internet. But right now, my laptop has, if you check IP config, it is a private IP. We'll see that what is private and public. Still has private IP, still connected to the internet. Okay. So public IP which connects directly to internet. If you use private IP, it will not connect to the internet. Private IP, IPs which will connect only in the local network. These private IPs will not connect to the internet. Public IPs only will be connected to the internet directly. If you have private IP, you cannot connect to the internet. Only within this building you can communicate. Okay. So IPs will be used to connect in local network. You need public IP if you want to connect to the internet. So from each class there are public IPs and private IPs. Class A 10.x refers to any IP in that series, and rest all are public IPs. Class B 172.16 is private, rest all public IPs. Class C 192.168.x.x, rest all are public IPs. From class A, these are the private IPs which will not connect to the internet. Class B, class C. Rest any IP, if you take outside this range, any IP you can directly connect to the internet. Okay. This is the reason we have selected, it's a small network and local network. So we have selected 192.168.1 in our lab as private IP from class C. Okay. So private IP from class C, and remaining all IP addresses are public IPs from the class C. Okay. So that's the reason 192.168 one dot series we are using in our lab. Small network and private IPs. Okay. Fine. These public IPs are not enough. From IPv4, these public IPs are not enough. It's almost like exhausted. Many devices across worldwide directly connected to the internet. That's why these IPs are almost over. Okay. That's why IPv6 was developed. It's a 128-bit long hexadecimal address. 4 times to IPv4, and it's 0 to 9 and A to F combination will be there. Okay. If you see an example, IPv6 example, you get here, it will be like this. This long. We can't even identify, we can't even remember one IP also. If it is IPv4, at least few numbers we can remember. 192, 168, 1.200 is vCenter, 1.240 is host. Few IPs we can remember. If it is this long and hexadecimal, we can't even remember one name also, one number also. Okay, but we get a lot of IP addresses to connect in the network. Many IPs, we get lots and lots of IP addresses compared to IPv4. IPv6 also is in usage now. Many people are already using IPv6. Okay, fine. So that's why IPv6 is developed compared to IPv4 because of the addresses are exhausted. Now understood what is public versus private? So now we'll check. In my laptop, there is a private IP, but still I'm getting internet. Okay, that's why I've connected, right? You all connected and we are discussing something. Okay. How is it happening? We'll see here. This is my laptop. This is Wi-Fi modem. Internet connect. Internet. If you want to connect to internet, if you want to connect your laptop to internet directly, you need to purchase public IP from the service providers. So here what we are doing, right? We are taking Wi-Fi connection from ACT or Airtel, Jio, whatever it is. Okay? Once you take this connection, this end there will be one public IP, and this Wi-Fi modem will have one private network here, one private IP at the other end. Here also we will assign the same private IP, not a same one from the same network. So here we have assigned 192.168.1.5. So here 1.1. This has 92.168.1.0/24. So this Wi-Fi modem has these many IP addresses. Total 256 IPs, out of which 253 are usable. Okay, one is connected here, remaining 253 we can use. Okay. So now this Wi-Fi modem where we are connected, the other end has private IP, wherever my laptop is also connected. The other end, Wi-Fi, the other end it has public IP, which is connected to the internet. The cable is coming from the internet service provider directly. Okay. Here they have assigned one public IP also. We'll see how to check this public IP also. Okay. And now itself we'll see. If you want to know the public IP from whatever it is, let's say we'll just think that 23.5.6.7, something like this. This is public IP range. Now, up to here we have internet. We have taken internet connection from the service provider, right? Up to here there is a public IP so that it is connected to the internet directly. If you want to connect your laptop to directly with a cable, you need to assign this address on your laptop. Okay, but I have not assigned. I have my only private IP. So up to here there is internet service. Up to here it is local network. This Wi-Fi modem that you purchase has a feature of converting the services from one end to another end. That means whatever the services which are available on the public IP end will be shared with private IP end. That means internet connection which is available here will be shared to the private IP which is on the other end. This has that inbuilt mechanism. It It's called NATing also, Network Address Translation. It does NATing to transfer the services from here to here. The network services will be shared. Fine. That's how once the services are shared from public end to the private end. So any device, these are local network. This is already a local network. Internet service is available here. Now any device can use internet service. That's what it happens when you connect your mobile or laptop to any Wi-Fi modem. With wired connection or with wireless, whatever it may be, same thing happens. From here, your mobile will be locally connected to the Wi-Fi modem, and where these services will be shared. That's how even I have my private IP on my laptop. I'm getting internet services. Fine. That is the understanding of public IP versus private. Even if I have private IP, because of this NATing on the Wi-Fi modem, it is translating the services. But I'm connected to internet using this one only, this public IP only. So if you want to know what is the public IP from the Wi-Fi modem end, you can open Google and type what is my IP. Here is the public IP. This is the one. Like this it is happening. Just type in Google what is my IP, you will get your public IP. How are you connected? Fine. This is how it is connected. Public IP versus private IP. Any questions here? Now, if you want to connect multiple devices together, let's say you have two computers to connect together. You will connect with a cable between those two computers and they will communicate together. What if you have three devices? One is already connected here, right? With a cable, you already connected like this. You cannot connect the third one directly to here because your laptop had only one port. Okay, you cannot connect the second one. So for that, what you need to do? If you want to connect multiple devices together, okay, you need to buy network device. Okay, networking devices. But if you want to connect multiple devices together, you need to buy networking devices. In that, first one is called hub. Okay. You need to buy basic network device. It will have 2 or 4 or 8 ports. Okay. 248 we get. So connect to this device. You can connect up to 8 device. Like this. Multiple devices you can connect together. Okay. Now, so here how the communication will happen. We'll have to understand basic communication through these devices. So any computer, here you also assign one IP address from class C. Here also IP you have assigned. Everything is good. IP from class C. Even though you have assigned IP address to communicate from one computer to another computer, it will use the MAC address to send and receive the traffic to the destination. So MAC address, media access controller. Same like WWN, it will have MAC address on the network interface card. Okay. So if you are sending, let's say you are sitting here. Your friend is sitting here. You are trying to send some data here, or maybe this is a printer. You are trying to send some print from here to here to print that paper. From this laptop, you are trying to print it. Okay. So that communication happens via a message packet. It's called a packet. This computer will prepare this message packet. Source MAC. In this packet, it will have source MAC, destination MAC, and data. You are trying to send, let's say, hi message. This computer will prepare this message packet with the source MAC address, that is MAC address on this network interface card, destination MAC address where it's supposed to go, and data, what data you are sending, let's say hi message. This computer will prepare this packet. Okay. Now we'll try to see what is the MAC address. Let's put some, just for example. This is the MAC address here. I'm changing only the last value so that it will be easy to identify. Okay. 3 different MAC addresses are there. When you are sending some packet from this computer, this MAC address will be filled here. Okay. Destination will be 50. Okay. Like this. Destination MAC, it will fill here. Source MAC address, it will fill here, and data. When this packet travel to the hub, from here it will go to the hub. This hub will not be aware where to send it. What it will do, it will send a copy here, it will send a copy here, it will send a copy to this computer also. All the connected devices will get a copy of this message. This message packet will be delivered here, here, here as well. This machine will not accept because this MAC is not matching here. This machine will accept that because MAC is matching there. And this machine also will drop it because destination MAC is not matching. So now unnecessarily it has to send 2 copies, one here and another one here. If this computer is replying with a hello message, that also will be sent to this computer, this one. It's like one to many all the time, and finally it will be many to many. Unnecessary communication will happen on this switch or this device hub. But basic, that's why it's called dummy device. It's a basic network device. It's a dummy device. Yeah, because it is not managing properly. It is sending a copy to everybody. Right? So you don't need to worry about these things. We will not be working with these devices. Just we are trying to understand some data transfer mechanism. Okay, so because of this is a dummy device, Next level device is very, very important. In your day-to-day job, it will be very useful. Okay. Next device is switch. This works in layer 2. What layer it is? It's called intelligent device also. Okay. So these layers are about OSA layers. Anyone remember how many OSA layers will be there?
Seven.
Yes, 7 OSA layers will be there. In that 7 layers, it will work in from second layer, from bottom. Top to bottom 7 layers will be there. So it will work in the second layer. So it will have number of ports starting from 24, 48, 96, 128. Okay, number of ports will be there. And it will also have port numbers here, this numbering. Okay, 12 ports are here. In our lab also we have this switch. We connected this device here, this one here. Like this. Multiple devices are connected. And MAC addresses, let's say here. Different MAC addresses. Recap. So here also, when it is sending a first packet, first let's say very first time, you just now you have got the switch. It will have source MAC, destination MAC, have data. This computer will prepare a message, and it let's say it is supposed to send data to this computer. You are here, okay? Here to this computer. So it will be filled up. I will write only the ending value. Destination address 4D. Here it is 4A. From 4A, it should go to 4D and some data. Okay, let's say hello data. Data. This packet supposed to deliver here. Fine. From here to this computer. Once it goes very first time, just now you have purchased the switch, connected some devices and initiating some traffic. Very first time, the packet will go to switch. Switch will not be aware where to send this information. What it will do, it works exactly like a hub. It will send a copy here, copy here, copy here. So to all the connected devices, it will send a copy. Same like hub. Then what is the difference here? We'll see what's the difference. Very first time, it will send that copy to all the devices. All the machines will drop it. Okay, this machine also will not accept. This machine only will accept it because this address matches only here. So this machine will accept that packet. Rest all the machines will drop it. Now what it will do after this, switch will have a memory. In its memory, it will store all this information. So here 1, 2, 3, 4, 5, 6. I'll mark it 12 here and ending. Okay. It will have a memory. The switch maintains its own memory. In that memory, it will have a table like this with the port numbers. Okay, on one side, one column, another one MAC address. If a packet is transferred from here to here, okay, that means that MAC address 4A is connected to port number 2. Okay, and it is delivered on port number 12. 4D is connected on port number 12. So it will write all the MAC addresses here. It will fill up this table. Fine. It will fill up this table with port IDs and the MAC address. Clear? Now, so remaining devices which did not accept the packet, they will reply. Negative message will be sent. I'm not the correct guy, I'm not the correct guy. That negative message also will have that MAC address from this device, from this device. So it will fill up all the values wherever it is connected. Number 5. Okay. See, like this. It will fill up all the time. Very first time it happens like this. Next time, your friend will reply, hello. That also will have packet like this. Source MAC address will be 4D and destination MAC address will be 4A. Here it should come, right? Okay. Write that packet here. Here source will be 4D and destination will be 4A. 4A. So that means once a packet enters into the switch, switch will open and see where is the destination. So it's 4A. It will check where is the MAC address ending with 4A. Total value. I'm just talking about only the final value. It will look for the entire value. MAC address ending with 4A. Here it is. Where it is connected? Port number 2. That packet will be directly delivered to the port number 2. Instead of sending a copy to all others, it will send one-to-one communication directly to this switch. So here there is no unnecessary communication. Hub does every time, but switch will do only first time. From second time onwards, it will be one-to-one communication. So that's why it maintains its own memory MAC table in its memory. That's why it's called intelligent device. It is automatically sending it to the correct device. Okay. Here. So in this way, it will happen one-to-one communication only from now onwards. Until you delete or you format the switch, it works the same way. It maintains the MAC addresses in the memory. This table is called MAC table. Very, very important. If you remember these two columns, you can explain the switch concept to anybody. Okay. If anyone asks any questions, also you can give. But the columns inside the MAC table, port ID and MAC address. Okay. Clear? Any questions? Fine. Okay. So it works in layer 2 and it's called intelligent device. But here, if you assign class A here and class C here, it will not work again. It should be from the same class here also. Fine.
సార్
Yes, please.
సెకండ్ టైం మనము రిప్లై ఇస్తాం కదా సార్, అప్పుడు మళ్ళీ ఇక్కడ మ్యాక్ టేబుల్లో స్టోర్ కదా మెమొరీలో.
Yeah, same to same, like second time from this computer, right? Ikkad nunchi kada. Yeah, when it replies, right, destination MAC address will be like this 4D. It will go and verify where is the MAC address ending with 4D here. It delivers directly packet to 12 only, port number 12 only.
ఓకే
It's fine. What if you want to connect between two different networks? You have an office. In one location, another office in another location. Here you are using class A IP addresses, here you are using class B IP address. If you want to connect these two together, directly it's not possible. So you need to have another network device called router. It works in layer 3. Layer 3 device. A router will be distinguished like this. Router configuration principle itself, okay, it will be like this. If you are using class A here, it should be class B or C on the other end. If you assign class A, even it will not work also. Okay, it should be class B only. So you need to purchase this kind of device if you want to communicate between two computers with the different classes. If you have a laptop with class A, another laptop with class B, if you want to directly communicate, they will not communicate. You need to buy a router, then it will work. Okay. So if you know this router will be used for this kind of purpose, is more than enough. Switch, you should know switch working principle. You should know properly. Okay. IPv4, IPv6, how to verify IP address which is assigned to Windows machine. How to verify what IP address is assigned to my laptop? I want to check. How can I check that?
Get
IP config without space. If I want to test connectivity between two computers, ping space, destination machine IP. If I want to check connectivity between my computer 1.5 and 192, 168, 1.200, ping space, enter. 200 is not reachable, it's down right now. 240, nothing is reachable. Okay, right now it is power outage here. All the devices are powered off, so that's why they are not reachable. Clear? Yeah. Any questions?
అదే గ్రూప్ చాట్లు అయితే ఎలా ఎలా కనెక్ట్ అవుతుందని?
Which one?
గ్రూప్ చాట్లు అయితే మామూలుగా ఒక మెసేజ్ సెండ్ చేస్తాం, ఒక అదర్ డెస్టినేషన్.
That is different. This is just basic communication explanation. So in that group chat, like it will be using common application. It will be sending it to the common machine. So like application is here. Or everybody will trying to send the communication to this line like this. From here, the copy will be visible to everybody.
Okay.
Just for example, I took that message concept. In that case, it will go to many only because it's supposed to deliver at many locations.
Okay.